Hello everyone. Today's topic is Laplace and inverse Laplace transform on periodic function. Okay, and in my last lecture we have completed all the uh, theorems, or you can say all the results of Laplace and inverse Laplace transform up to division property. Okay, and this topic, Laplace and inverse Laplace transform on periodic function, this is very important. Actually all the three topics, all the remaining three topics, periodic function, step function and convolution, these three topics are very important for your examination. Okay, also we have one more topic, that is solution of ODE using Laplace transform. This is also important. Okay, so let's start today's topic, Laplace and inverse Laplace transform on periodic function. So first of all, we have to understand what is periodic function. You know that if we can write any function, suppose f of x, if we can write any function f of x in this form, that f of x plus t, this is equals to f of x. Okay, for example, suppose f of x equals to sine x. Okay, and we know that sine x plus 2 pi, sine x plus 2 pi, this is equals to again sine x. Similarly, cos x plus 2 pi, this is equals to cos x. So you can see that if you add a particular number, a fixed number capital T, then you are getting the same function f of x. Okay, if you add 2 pi with sine x, then you are getting again the same function sine x. Okay, so this type of function is called periodic function. Okay, this type of function is called periodic function. That means after a period, and the period is t, after a period capital T, the function is repeating. Okay, suppose the curve of sine x, you know, this is the curve of sine x, x-axis, y-axis, and this is the curve. Okay, similarly on left hand side, this point is 0, this is pi, this is 2 pi. After this 2 pi region, you can see that the sine x curve is again, you are getting the same curve. Yes or no? Again you are getting the same curve. If you draw a mirror, now you can see that after 2 pi the curve is repeating. That's why the period of the function sine x is 2 pi. So similarly, the period of cos x is 2 pi, but the period of tan x is pi. Okay, so you must remember these three periods. For sine x, period is 2 pi, for cos x, period is 2 pi, and for tan x, period is pi. Okay, so this is the basic concept of periodic function. Now we have to find out, or we have to apply Laplace or inverse Laplace operator on periodic function. Okay, so let's understand the formula. Suppose we have a function f of x, f of t, because we are learning Laplace transform. So we have a function f of t. Obviously this function is periodic function. Periodic function. Okay, and also given the period of the function. Let's say the period of the function is capital T. Okay, so f of t, this is small t, variable t. F of t, this is our periodic function, and capital T, this is the period of the function. Then what will be the Laplace of this periodic function? Formula is Laplace of f of t, this is equals to 1 by 1 minus e to the power minus st, integration 0 to capital T e to the power minus st ft dt. Okay, So Laplace of f of t, that means Laplace of the periodic function is 1 by 1 minus e to the power minus st integration 0 to t e to the power minus st ft dt. Okay. Here you can see that this t, this is capital T, yes or no? And this integration limit, this t is capital T. But in this integral part, here all the t's are small t. Okay, that means here you have to use the variable t, but in integration limit and out of the integration sign, you have to use the period capital T. Okay, so under integration sign, you have to use the variable t, and in integration limit, upper limit of integration, that will be period capital T, and out of the integration sign, the capital, that will be capital T. Okay, so 1 by 1 minus e to the power minus st integration 0 to t e to the power minus st ft dt. Okay, this is the simple formula. Remember, period is always positive. Okay, period is always positive. Period negative is not possible. Okay, let's understand this topic by solving a question. Given this question is very, very important. Given f of t, this is equals to sine t. Okay, 0 less than t less than pi, and 0 pi less than t less than 2 pi. And extended periodically with period capital T, sorry, with period 2 pi. Okay, find Laplace of f of t. Find Laplace of f of t. So here the function f of t is given. Also it is given that it is extended periodically, and the period is also given 2 pi. Yes, so you can say that here capital T is equals to 2 pi. Yes, and f of t, this is equals to sine t when the region is 0 to t, 0 to pi, and 0 when the region is pi to 2 pi. Okay, now we have to apply Laplace transform. So according to the formula, Laplace of f of t, this is equals to 1 by 1 minus e to the power minus st, and capital T equals to 2 pi. So this will be 1 minus e to the power minus 2 pi s. Yes, so 1 minus e to the power minus 2 pi s. Okay, integration 0 to 2 pi. Okay, e to the power minus st into sine t. Actually not sine t, that will be ft, because here integration limit is 0 to 2 pi, ft ft dt. Okay, now for this ft, we have two different values for different regions. In 0 to pi, the value is sine t, and in pi to 2 pi, the value is 0. So we have to break this whole integration. So we can write 1 by 1 minus e to the power minus 2 pi s integration 0 to pi e to the power minus st into sine of t dt. Okay, plus integration pi to 2 pi e to the power minus st into, in pi to 2 pi the value is 0, so into 0 dt. Okay, now simplify this. So you are getting uh, this is equals to 1 by 1 minus e to the power minus 2 pi s integration, that will be 0 to pi, into integration e to the power minus st sine of t dt. Let's say this is equation number 1. Okay, now we have to find out the value of this integration. So let capital I is equals to integration 0 to pi e to the power minus st sine of t dt. Okay, we have a formula. The formula is integration e to the power ax sine bx. Okay, e to the power ax sine bx dx. This is equals to e to the power ax divided by a square plus b square into a sine bx minus b cos bx. Okay, this is the formula. Now we have to use this formula. So integration e to the power ax sine bx dx, this is equals to e to the power ax by a square plus b square, a sine bx minus b cos bx. Okay, so if we compare these two results, so here what is the value of a? What is the value of a? Here e to the power ax na, and you have e to the power minus st. That means a is equals to minus s. And what is the value of b? Here you have sine t, and this is sine bx. That means b is equals to 1. And here the variable is t, and in our formula the variable is x. So no problem. Okay, so a is equals to minus s and b is equals to 1. So let's apply the formula. So that will be e to the power a is equals to minus s. So e to the power minus st divided by a square plus b square. That means s square plus 1. Clear? Into a sine bx. A is equals to minus s. So that will be minus s into sine t. Okay, minus b cos bx. So minus cos of t. Okay, this is the formula. So minus minus s into sine t minus cos t. Okay, this is the value of I. This is the value of capital I. Okay, now here you can see that the integration limit is 0 to pi. So you have to put integration, not this part, whole part, 0 to pi. Here the variable is t, na? That means you have to put the upper limit and lower limit in place of t. So you are getting e to the power minus s pi divided by s square plus 1 into minus s into sine pi minus cos pi. This is the upper limit. Okay, minus we have to put lower limit. T is equals to 0. That means e to the power 0. E to the power 0 means 1. So 1 by s square plus 1 into minus s into sine 0 minus cos of 0. Okay, let's simplify this. Acha, sine pi, this is 0, and cos pi equals to minus 1. So minus minus plus 1. So you are getting e to the power minus s pi divided by s square plus 1. Okay, and here sine 0 equals to 0 and cos 0 equals to 1. Okay, cos 0 equals to 1. So that will be minus 1, minus minus plus 1. So you are getting plus 1 by s square plus 1. Okay, so finally the result is e to the power minus s pi plus 1 divided by s square plus 1. Okay, this is the value of capital I. Now you have to put this value in equation number 1. So Laplace of f of t, this is equals to 1 by 1 minus e to the power minus 2 pi s into the value of the integration is e to the power minus s pi plus 1 divided by s square plus 1. Okay, now just simplify this. E to the power minus s pi plus 1 divided by, this is e to the power minus 2 pi s. So 1 minus e to the power minus 2 pi s. We can write in this form that 1 square minus e to the power minus pi s whole square. Yes or no? Because we know that a to the power m whole to the power n, this is equals to a to the power mn by index formula. So obviously we can write in this form. And this is of the form a square minus b square. Yes. And we know the formula a plus b into a minus b. So that will be 1 plus e to the power minus pi s into 1 minus e to the power minus pi s. Okay, so let's put this value 1 plus e to the power minus pi s into 1 minus e to the power minus pi s into this value s square plus 1. Okay, here you can see 1 plus e to the power minus s pi and 1 plus e to the power minus s pi cancel. So you are getting 1 by 1 minus e to the power minus pi s into s square plus 1. This is the final result. Okay, so this is quite lengthy problem. You have to solve this question step by step. Here you have to remember this formula, because otherwise you can find out the value of the integration by taking I and applying integration by parts formula. Clear? Let's solve another problem of periodic function. Question. Find Laplace and find Laplace transform. Find Laplace transform of a periodic function capital F of t. Okay, given by f of t, this is equals to t when 0 less than t less than c, and 2c minus t when c less than t less than 2c. Okay, you have to find out the Laplace of this function. But problem is, in this question the period is not given. So what will be the period for the periodic function f of t? Very simple process is just subtract upper limit minus lower limit. Okay, upper limit minus lower limit. What is the upper limit? This 2c, and what is the lower limit? This 0. So 2c minus 0, this is equals to 2c. So this is the period of the function. Okay, so this is our capital T. So you can write here f of t, this is equals to t when 0 less than t less than c, 2c minus t when c less than t less than 2c. This is our given function, and period capital T equals to 2c. Okay, period capital T equals to 2c. So let's solve it. Laplace of f of t, this is equals to 1 by 1 minus e to the power minus 2cs. Okay, integration 0 to 2c e to the power minus st f of t dt. Okay, since we have two different values for different regions, So we have to break this integration. So 1 minus e to the power minus 2cs integration 0 to c e to the power minus st into, in 0 to c, the value of the function is small t. So e to the power minus st into t dt. Okay. Plus integration c to 2c e to the power minus st, and in c to 2c you can see the value of the function is 2c minus t. So 2c minus t dt. Okay. Now you have to integrate this. Okay. You have to apply integration by parts. So this is equals to, you can write it, this is equation number 1. Okay. And separately find out the value of the integration. Okay. So first let's calculate integration 0 to c e to the power minus st into t. So integration 0 to c t into e to the power minus st dt. Okay. So here first function is t. So t into integration e to the power minus st dt minus integration ddt of t integration e to the power minus st dt whole integration. Okay, this is the formula. So that will be t e to the power minus st divided by minus s minus integration. Derivative of t is 1 and e to the power minus st divided by minus s dt. So you are getting, obviously here the integration limit is 0 to c. Similarly here integration limit is 0 to c. Okay. T e to the power minus st divided by minus s. This minus minus plus e to the power minus plus 1 by s into integration of e to the power minus st. So that will be e to the power minus st divided by minus s 0 to c. So you are getting t e to the power minus st divided by minus s plus minus e to the power minus st divided by s square. Okay. Now put upper limit minus lower limit. Okay. So you are getting c e to the power minus cs divided by minus s minus e to the power minus cs divided by s square. This is upper limit. Okay. Minus lower limit. If you put t equals to 0, so this part will be 0 because t is multiplied. Yes. So this part will be 0. So you are getting minus e to the power 0 means 1 divided by s square. So this is equals to c e to the power minus cs divided by minus s minus e to the power minus cs divided by s square plus 1 by s square. This is the integral value of the first part. Okay. Now we have to calculate the integration of the second part. So next part is integration 0 to integration c to 2c. Integration c to 2c minus t into e to the power minus st dt. Okay. So let's solve it step by step. So 2c minus t, that will be our first function. Integration c to 2c e to the power minus st dt minus integration derivative of first function. So ddt of 2c minus t. Integration of second function. So e to the power minus st dt, then whole integration. Okay. So you are getting 2c minus t into here e to the power minus st divided by minus s minus integration derivative of 2c minus t, that will be minus 1. Yes, and minus minus plus. So you are getting e to the power minus st divided by minus s dt. And the limit is integration c to 2c. So this is equals to this is equals to 2c minus t into e to the power minus st divided by minus s, and this is plus minus minus 1 by s into e to the power minus st divided by minus s, c to 2c. So 2c minus t into e to the power minus st divided by minus s, this is minus minus plus 1 by s square, actually e to the power minus st by s square, e to the power minus st by s square, c to 2c. Now put upper limit. If you put upper limit to c, so this part will be 0. Yes or no? This part will be 0. So from here you are getting e to the power minus 2cs divided by s square. This is upper limit minus lower limit. If you put t equals to 0, so this will be minus 2c e to the power minus st. If you put t equals to c, so this will be, just a minute, I am putting lower limit t equals to c. So this is c into e to the power minus cs, e to the power minus cs divided by s. Yes, let me check again. First part is upper limit 2c, 2cs by s square minus lower limit. So if I put c, that will be c e to the power minus cs divided by s, and this is minus minus plus. Okay, now minus, you have to put t equals to c, so minus sc divided by s square. This is the answer. Okay, so e to the power minus 2cs divided by s square plus c e to the power minus cs divided by s minus e to the power minus cs divided by s square. Now put these two values in equation number 1. Okay, so Laplace of f of t, this is equals to 1 minus e to the power minus 2cs into, the value is, this is our equation number 1. Here you can see this is our equation number 1. First integration value is c e to the power minus cs. This, just put this value. Okay, so you are getting c e to the power minus cs divided by minus s plus plus e to the power minus cs divided by s square plus 1 by s square. This is for the first integration, plus the second integration, e to the power minus 2cs divided by s square plus c e to the power minus cs divided by s minus e to the power minus cs divided by s square. Okay, so this is equals to now from here, if you simplify, you can see that these integrations, these values are cancelled. This one cancelled. Okay, also here you can see c e to the power minus cs divided by s, and this is c to the power minus cs divided by minus s, so this part is also cancelled. So you are getting 1 by 1 minus e to the power minus 2cs into 1 plus e to the power minus 2cs divided by s square. Okay, so the final answer is 1 by s square into 1 plus e to the power minus 2cs divided by 1 minus e to the power minus 2cs. Okay, so just these problems are quite lengthy problems, so you have to solve uh, each and every step in full mind. Okay, I hope this topic of periodic function is very simple and very easy now. Just try to solve more problems from your question bank. There are many problems on periodic function in your question bank. Okay, try to solve this. Thank you so much.